Hello, in this lecture we'll find out the value of angle theta. In the drawing we have triangle ABC. Triangle ABC is an isosceles triangle because side CA equals to side CB. In addition, you know that this angle ACB equals to 20 degrees in its size. This angle NAB equals to 50 degrees in its size. This angle MBA equals to 60 degrees in its size. Our mission is to find out the value of the size of angle NMB, this angle. This is actually angle theta. So, first of all, I will copy triangle ABC in a new page and we will analyze this triangle ABC. Okay, this is triangle ABC, this is a copy from the original drawing. Side CA equals to side CB, this angle ACB is equal to 20 degrees in size. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that must be also equal to each other. So if one angle is theta, then the other angle must be also equal to theta. In inside triangle ABC, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. For which angles we have inside triangle ABC, we have this angle is equal to 20 degrees in size. Theta plus theta is 2 theta plus 2 theta. In total, they must be equal to 180 degrees. We subtract 20 degrees from this equation, and we get that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. So 2 theta equals to 160 degrees. We divide this equation by 2, and you get that angle theta equals to 160 degrees over 2, it is 80 degrees. Okay, so this angle theta equals to 80 degrees, and this angle theta is also equals to 80 degrees. So this is angle theta that is equal to 80 degrees. But because of the fact that part of angle theta it is already this angle equals to 50 degrees, therefore the missing angle must be equal to 30 degrees. In order to complete the size of angle theta, this angle to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees in its size. But because of the fact that part of angle theta equals this angle MBA equals to 60 degrees, therefore the missing angle must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here NBA and VM must be equal to 80 degrees in its size. In the next step, I'll copy triangle NAB in the new page and we'll analyze this triangle NAB. angle NAB equals to 50 degrees. And this angle NBA equals to 80 degrees. This is angle theta. So actually, this is triangle NAB, this is the curvature of the original drawing. We define the missing angle is theta. The sum of the angles in triangle NAB must be equal to 180 degrees, therefore 50 degrees plus 80 degrees plus angle theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130. We subtract 130 degrees from this equation, and we get that angle theta equals to 180 degrees minus 180 degrees minus 130 degrees. It is 50 degrees. So I found out that this angle theta, that is actually angle NAB equals to 50 degrees in its size. So I write it down here. Angle NAB equals to 50 degrees in its size. We continue to focus on triangle A and B. On triangle A and B, we have those two angles that are equal to each other, and we have the root that in front of rival angles in the triangle are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other. So here, side AB equals to side NB. AB equals to NB. I'll write it down here. The side AB equal to side NB. Side AB, this is side AB, this is equal to side NB. Okay. In the next step, we'll focus on triangle A and B. This triangle, so I'll copy triangle A and B in the new page, and we'll analyze this triangle, triangle A and B. So, this is angle theta, actually angle MBA, this angle is equal to 60 degrees. Angle MAB, this angle, it is angle theta that is equal to 80 degrees. So actually, this is triangle A and B that are covered from the original drawing. We define the missing angle here as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say 80 degrees plus 60 degrees plus the missing angle, that is angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 degrees plus 60 degrees is 140 degrees, plus theta must be equal to 180 degrees. We subtract 140 degrees from this equation, and we get that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So if the missing angle theta equals to 40 degrees in its size, that is to say angle A and B equals to 40 degrees. This is angle A and B that is equal to 40 degrees in its size. In the next step, we'll do a construction. That is to say, from point B, we draw line segment BD on CA in such a way that BD will be equal to BA. Okay. So this is 9 cement BD, and according to our construction, side BD equals to side AB. BD equals to side AB according to our construction. BD equals to side AB. Write it down. BD equals to side AB according to our construction. In the next step, we'll focus on triangle ADB, this triangle ADB. So I copy triangle ADB in a new page and we will analyze it. This is angle theta that is equal to 80 degrees. And again, AB equals to DB according to our construction. AB equals to DB according to our construction. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So in front of those two sides we have those two angles that must be also equal to each other. But this angle equals to 80 degrees, therefore this angle must be also equal to 80 degrees. So I found out that this angle ADB equals to 80 degrees in its side, so I write it down here. This is angle ADB that is equal to 80 degrees in its size. So we continue to focus on triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have 80 degrees plus 80 degrees, and we define the missing angle as theta plus theta. In total, the sum of those three angles must be equal to 180 degrees. So 80 degrees plus 80 degrees is 160 degrees plus theta. In total, it must be equal to 180 degrees. We subtract 160 degrees from this equation, and finally we get that angle theta, the missing angle theta, equals to 180 degrees minus 160 degrees, it is 20 degrees. So this is the missing angle theta that is equal to 80 degrees in its side. So actually we found out that angle ABD equals to 80 degrees in its size. So I write it down here. This is angle ABD that is equal to 20 degrees in its size. So here we have the small angle ABD equals to 80 degrees in its size. The big angle ABM equals to 60 degrees in size. Therefore, the big angle that is equal to 60 degrees minus the small angle that is equal to 80 degrees must be equal to the missing angle that is actually angle MBD. Okay, the big angle minus the small angle equals to the missing angle MBD. So I write it down. The big angle ABM this angle that is equal to 60 degrees in its size, minus the small angle that is actually angle ABD that is equal to 20 degrees in its size, must be equal to the missing angle that is actually angle DBM. Repeat again. The big angle ABM that is equal to 60 degrees in size minus the small angle that is angle ABD that is equal to 20 degrees in size must be equal to the missing angle DBM. So the big angle equals to 60 degrees, the small angle equals to 20 degrees, 60 degrees minus 20 degrees, it is 40 degrees, therefore the missing angle DBM must be equal to 40 degrees in its size. Yeah, this is angle DBM. This is the missing angle DBM. It must be equal to 40 degrees in its size. In the next step, we focus on triangle DMB. So I copy triangle DMB in a new page and we will analyze it. This is angle DMB that is equal to 40 degrees. And we just right now found out that angle MBD equals to 40 degrees also. So actually, this is triangle MDB that I call from the original drawing. Those triangles are both equal to 40 degrees, therefore they are equal to each other. Again, we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of those two angles, we have those two sides that must be equal to each other. That is to say, side DM must be equal to side DB. DM equals to DB. DM equals to DB. So we can write here, inside DM equals to side DB. Side DM equals to side DB. So here, on one side, AB equals to NB. Here, from this equation, AB equals to NB. From the other side, AB equals to BD. AB equals to BD. And from this equation, BD equals to AB equals to NB, we will derive that BD equals to NB. BD equals to NB. Here, side BD equals to side NB. We already found that those two sides are equal to each other, but I also proved it in another way. BD equals to NB. Okay. So, in the next step, we'll join points D and N together by a straight line. And we will focus on the right triangle, triangle DNB. copy triangle DNB in a new page and we will analyze it. Angle NBD, this angle equals to 40 degrees plus 20 degrees, it is 60 degrees. So angle NPD equals to 60 degrees. And again, we've already found out that NB equals to BD. BD equals to NB. BD equals to NB. So actually, this is triangle DNB that I copy from the original drawing. NB equals to DB. Again, according to the same rule that in front of equal sides in the triangle there are equal angles, those two sides are equal to each other, therefore they are located in front of those two angles that also must be equal to each other. So if one of these angles is theta, the other angle must be also equal to theta, and the sum of the angles in triangle DNB must be equal to 180 degrees. So which angles we have in triangle DNB? We have theta plus theta, that is 2 theta, plus 60 degrees. In total, the sum of those three angles must be equal to 180 degrees. So we subtract 60 degrees from this equation, and we get that 2 theta equals to 180 degrees minus 60 degrees, it is 120 degrees. We divide this equation by 2, and finally we get that angle theta equals to 180 over 2 is 60 degrees. Angle theta equals to 60 degrees in its side. So this is angle theta that is equal to 60 degrees. And this is also angle theta that is equal to 60 degrees. So we actually found out that inside triangle DNB we have three angles that all of them are equal to 60 degrees in their sizes. Therefore triangle DNB is an equilateral triangle. Okay, so I write it down. Triangle DNB is an equilateral triangle. And we also know that in any equilateral triangle all the sides are equal to each other. Therefore triangle, equilateral triangle DNB, side DN equals to side NB equals to side DB. DN equals to NB equals to DB. I write it down here. DN equals to DB equals to NB. dN equals to NB equals to dB. So here from one side, according to this equation, dB equals to dm. Here dB equals to dm. From the other side, from this equation, you can see that dB equals to dn. dB equals to dn. And from this equation, dm equals to dB equals to dn, we will derive that dm equals to dn. dm equals to dn. dm equals to dn. Yeah. dn equals to dn. In the next step, we will focus on the straight line CA. On this side of the straight line CA, it's point D. So, which angles we have on this side of CA, it's point D. We have this angle that is equal to 80 degrees in its size. This angle is one out of 3 angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees. And we have here missing angle. So those are the angles we have at this side of the straight line CA at point D. 80 degrees plus 60 degrees plus the missing angle. In total, the sum of those 3 angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So 180 degrees plus 60 degrees, it is 140 degrees. Therefore, the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line CA at point D to 180 degrees, the missing angle must be equal to 40 degrees in its size. So, yeah, this is the missing angle MDN must be equal to 40 degrees in its size. Okay. In the next step, I'll copy triangle MDN in a new page and we'll analyze it. Again, angle MDN equals to 40 degrees. And we have already found out that dm equals to dn. Yeah, dm equals to dn. Okay. Side dm equals to side dn. So this is triangle DMN that I copied from the original drawing. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So in front of those 2 equal sides, we have those 2 angles that must be also equal to each other. So if this angle is theta, then the second angle must be also equal to theta, and the sum of the angles in triangle DMN must be equal to 180 degrees. So which angles we have in triangle DMN? Theta plus theta is 2 theta, plus 40 degrees. In total, they must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 180 degrees minus 40 degrees, it is 140 degrees. So 2 theta equals to 140 degrees, we will divide this equation by 2, and finally we will get that angle theta equals to 140 over 2, it is 70 degrees. angle theta equals to 70 degrees in its size, so angle DMN equals to 70 degrees in its size. So actually, this is angle DMN, the big angle DMN equals to 70 degrees in its size. So the big angle DMN equals to 70 degrees. Minus the small angle, that is actually angle DMB. That is equal to 40 degrees in its size. So the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta, that is actually angle NMB. It's very easy to see from the drawing that the big angle NMB minus the small angle DMB must be equal to the missing angle NMB. Repeat again. The big angle DMN that is equal to 70 degrees minus the small angle DMB that is equal to 40 degrees must be equal to the missing angle, angle theta, that is angle NMB, that is the angle that we are looking for. 70 minus 40 is 30 degrees. So the missing angle theta, that is the angle that we are looking for, that is also equals to angle NMB, equals to 30 degrees in its size. That is the answer to the question. This is angle theta, this is angle NMB, that is equal to 30 degrees in its size. So in the next step I'll summarize the lecture. So in this lecture, we found out the size of this angle, angle NMB, that is equal to theta. We have triangle ABC that is an isosceles triangle, that is to say side CA equals to side CB. In addition, in triangle ACB, angle ACB equals to 20 degrees. This is angle NAB that is equal to 50 degrees. And finally, angle MBA, this angle equals to 60 degrees in its size. Our mission is to find out the size of angle NMB that is equal to theta. So first of all, I copy triangle ABC in a new page and we analyze triangle ABC. So this is triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees in its size. Those two sides are equal to each other. CA equals to CB according to what is given us in the question. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are equal, that are located in front of equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in the triangle is equal to 180 degrees, especially it is so in triangle ABC. So which angles we have in triangle ABC? We have theta plus theta, that is 2 theta plus 20 degrees. In total, they must be equal to 180 degrees. We subtracted 20 degrees from this equation and found out that 2 theta equals to 180 minus 160. This is 180 minus 20. This is 160. So 2 theta equals to 160 degrees. We divided this equation by 2 and found out that theta equals to 160 over 2, that is 80 degrees. So angle theta equals to 80 degrees. Those two angles theta, each of them equals to 80 degrees in their sizes. So here, this is actually angle theta, that in total it is equal to 80 degrees. But this angle, angle A and B, it is part of angle theta, and it is already equal to 50 degrees. So for the missing angle, must be equal to 30 degrees. In order to complete this, the size of angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but part of angle theta that is actually angle DBA, it is already equals to 60 degrees, therefore the missing angle must be equal to 20 degrees. Again, in order to complete the size of angle theta to 80 degrees, the missing angle here, angle and BM must be equal to 20 degrees. Then we focus on triangle NAB, so I copy triangle NAB in the operation and we analyze it. This is triangle NAB, angle NAB equals to 50 degrees, angle NBA equals to 80 degrees, it is angle theta, and we have here, this is the missing angle, that we define this angle theta. In triangle NAB, the sum of the angles must be equal to 180 degrees. So which angles we have? Triangle ABC, we have this angle is equal to 50 degrees, plus this angle is equal to 80 degrees, plus this angle is equal to theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80, it is 130, so we subtracted 130 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So the missing angle theta equals to 50 degrees in its size. Angle theta is angle A and B that is equal to 50 degrees. Here, angle A and B equals to 50 degrees in its size. Then we continue to focus on triangle A and B. In triangle A and B, those two angles are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front, the equal angles must be also equal to each other. That is to say, AB equals to NB. AB equals to NB, and then also side AB equals to side NB. Okay. In the next step, we focus on triangle MBA. This is triangle MBA that I copied from the original drawing. Angle MBA equals to 60 degrees in its size. This is angle theta that is equal to 80 degrees. MBA equals to 60 degrees. This angle MAB equals to 80 degrees, and this is the missing angle that we define as theta. The sum of the angles in triangle A and B must be equal to 180 degrees. So which angles we have in triangle MAB? We have this angle that is equal to 80 degrees, this angle equals to 60 degrees, plus this angle that is equal to theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140, plus theta equals to 180. We subtracted 140 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So this angle A and B, equals to 40 degrees in its size. This is angle A and B, that is equal to 40 degrees in its size. In the next step, we did the construction, that is to say, from point B, we draw line segment BD in such a way, we draw line segment BD on CA in such a way that BD will be equal to BA. Again, BD equals to BA according to our construction. BD equals to BA according to our construction. So here, BD equals to BA, and then we copied triangle ADB in a new page and we analyzed it. This is triangle ADB that I copied from the original drawing. This is angle theta that we calculated the size of it in the beginning of the lecture, that is equal to 80 degrees. Those two angles are the missing angles. Again, AB equals to AD according to our construction. Those two sides are equal to each other according to our construction. And we have the order in front of equal sides in the triangle, they are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. So angle ADB equals to 80 degrees in its size. This is angle ADB that is equal to 80 degrees in its size. We continue to focus on triangle ADB. The sum of the angles inside triangle ADB must be equal to 180 degrees. So which angles we have in triangle ADB? we have 80 degrees plus 80 degrees plus angle theta, the missing angle is theta. In total, they must be equal to 180 degrees. 80 plus 80 is 160, so 160 degrees plus theta equals to 180 degrees. We subtracted 160 degrees from this equation and finally found out that angle theta equals to 180 minus 160, this is 20 degrees. So this is the missing angle theta that is equal to 20 degrees in its size. So actually angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So here we have angle ABD. We just right now found out that it is equal to 20 degrees in its size. This is the small angle. The big angle is angle MBA that is equal to 60 degrees in its size. So the big angle, that is angle MBA, minus the small angle, that is angle DBA, must be equal to the missing angle, angle MBD. Again, the big angle MBA minus the small angle DBA must be equal to the missing angle, that is angle MBD. Repeat again. The big angle is actually MBM that is equal to 60 degrees in size, minus the small angle that is angle MBD that is equal to 20 degrees, must be equal to the missing angle DBM. Okay. So 60 minus 20 is 40. So found out that the missing angle DBM equals to 40 degrees in its size. This is the missing angle DBM that is equal to 40 degrees in its size. Then we focus on triangle MBD. So I copy triangle MBD in this new page and we analyze this triangle MBD. We just right now found out that MBD, angle MBD equals to 40 degrees in size. We have already found out that this angle DMB equals to 40 degrees in size. This is angle DMB. Okay. So here we have in triangle MBD, those two angles, they are equal to each other. They are both equal to 40 degrees, therefore they are equal to each other. Again, we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be also equal to each other. That is to say, DM equals to BD. Again, DM equals to BD. Here, DM equals to DB, side DM equals to side DB. Okay? And here, AB equals to NB. From this equation, we know that AB equals to NB from one side. But from the other side, AB also equals to BD. AB equals also to BD. And from this equation, BD equals to AB equals to NB, we will derive that BD equals to NB. BD equals to NB. Side BD equals to side NB. Okay? In the next step, I join points D and N together by a straight line, and then we focused on the green triangle DNB. We analyze this green triangle DNB. So I copy triangle DNB in a new page and we analyze it. The size of angle NBD is equal to 20 degrees plus 40 degrees, that is 60 degrees. And also we know that DB equals to NB. Okay, again, this is triangle DNB that I copied from the original drawing, and NBD equals to 60 degrees, and side DB equals to side NB. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle DNB must be equal to 180 degrees. That is to say, theta plus theta is 2 theta plus 60 degrees. In total, they must be equal to 180 degrees. We subtracted 60 degrees for this equation and found out finally that 2 theta equals to 180 minus 120, 180 minus 60, subtract 60 degrees, so 180 minus 60, this is 120. So 2 theta equals to 120 degrees. We divided this equation by 2, and finally we found out that angle theta equals to 120 degrees over 2, it is 60 degrees. So we found out that this angle theta equals to 60 degrees, and this is angle theta that is equal to 60 degrees. Actually, in triangle DNB, we have all the three angles that are equal to 60 degrees in their sizes, therefore triangle DNB is an equilateral triangle. Okay, yeah. Triangle DNB, the great triangle DNB is an equilateral triangle. And we know that in any equilateral triangle, all the sides are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. Here we found that the BD equals to AB equals to NB. And also BB equals to DN equals to NB. Okay. So we have, what is the value of line segment DB? From one side, DB equals to DM. Yeah, DB equals to DM. DB equals to DM. But from the other side, DB also equals to ND. So we can write here that DB equals to ND. And from this equation, DB equals to DM equals to DB equals to DN. DM equals to DB equals to DN. We will derive that DM equals to DN. Again, DM equals to DN. Here, DM equals to DN. Okay. Then we focused on this side of the straight line CA at point D. We focus on this side of the straight line CA at point D. So which angles we have on this side of CA at point D? We have this angle that is equal to 80 degrees. This angle is one out of the three angles of the equilateral triangle, therefore it must be equal to 60 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Again, 80 degrees plus 60 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that I mentioned. 80 plus 60 is 140. Therefore, the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line CA at point D to 180 degrees, the missing angle must be equal to 40 degrees. So the missing angle here is angle MDN that is equal to 40 degrees. Okay, then I copied triangle MDN in a new page and we analyze this triangle. Again, this angle MDN equals to 40 degrees, and we already found out that DM equals to DN. I repeat again, this is triangle DMN that I copied from the original drawing. Angle MDN equals to 40 degrees, and we found out that DM equals to DN. Yeah. DM equals to DN. So again, we have the same rule that in front of equal sides in the triangle are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DMN must be equal to 180 degrees. That is to say, theta plus theta is 2 theta plus 40 degrees. In total, the sum of those four three angles must be equal to 180 degrees. So 2 theta plus 40 degrees equals to 180 degrees. We subtracted 40 degrees from this equation, and finally we found out that 2 theta equals to 180 degrees minus 180 degrees minus 40 degrees, it is 140 degrees. So 2 theta equals to 140 degrees, we divided this equation by 2, and finally we found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So this is angle theta, that is angle DMN, it is equal to 70 degrees. Again, this is angle theta, that is angle DMN, that is equal to 70 degrees in its size. So the big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees must be equal to the missing angle, angle theta, that is the angle that we are looking for. Repeat again. The big angle, that is angle DMN, that is equal to 70 degrees in its size, minus the small angle, that is angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle, angle NMB, that is equal to angle theta. So 7 and DMN equal to 70 degrees, the small angle DMB equals to 40 degrees, 70 degrees minus 40 degrees, it is 30 degrees. So in conclusion, found out that the missing angle, angle theta, the angle that we are looking for, angle NMB, equals to 30 degrees in its size. Okay, thank you very much.